All right, so we are in, well, unofficially BC Calculus. We're doing lesson 2-1. I pronounce this El Hospital. I don't know if the accent is right, but it's not hospital. A lot of textbooks, because the modern spelling does have an S in it, I figured that I would do kind of the more old school spelling, but El Hospital's rule. Yeah, so how do we use that rule? Let's find out. What is our objective today? Anyone with a quiet raised hand? Not a single person. Take a laptop shot. Yes, go for James.
Use El Hospital rule when encountering an indeterminate form like 0 over 0 or infinity over.
There it is. Thank you. So that word is hard, indeterminate form. And there are many types of forms. Here they are. 0 times infinity. It's kind of a contradiction because infinity isn't a number, it's this concept. Well, anything times infinity is infinity, but anything times 0 is 0, so what's 0 times infinity? It's these conundrums, right? So infinity minus infinity, is that 0 or infinity? We don't know. And there's no formal answer. 0 to the power of 0, also don't know. None of these you know, because theoretically, you could never divide by 0, but that's still indeterminate form. So you guys probably remember asking, well, what happened with 0 divided by 0? Maybe you asked in 8th grade, Algebra 1, I don't know. But that's an indeterminate form. We can now have an answer to that depending on the type of function you're talking about. It's the function that gives you 0 divided by 0, and depending on your analysis of that function, you could be like, oh, it's actually 3 in this case. Or, oh, it's actually 1/2. So I'm teaching you these last two. So can we circle the last two? Those are the ones that we are going to be dealing with. There's not really, well, there is, but not in this class, an answer to the ones on the left. As long as you define these by functions, you can answer that question. So, when are we ever going to use this? It's whenever you take a limit as x approaches some number where you have a fraction. A fraction where a function divided by function is equal to either 0 over 0 or infinity over infinity. These are the only two cases that we're dealing with. That's why we circled these two. These two are those two cases right there. Oh, I guess I could have put here. We should have put the infinity over infinity right here.
I was wondering about that.
It's like, I wrote two of them. All right, so here is your rule. If you have that function where it's a function on the top, function on the bottom, all you have to do is take the derivative of the top, f prime of x, and take the derivative of the bottom, g prime of x. Done. And I say done like it's easy, but what if I gave you a hard thing to take the derivative of? And I'm not going to, and neither will the AP test if you decide to take AP Calculus. They'll give you nice, easy ones. The hardest thing they'll ever give you, and the hardest thing I will ever give you, is a natural log. But you know natural log. Derivative of natural log of inner is?
Is it 1 over?
Yeah, arrow, say it louder.
1 over inner?
Yeah, so as a note, the hardest thing I can say, dx of natural log of x is equal to 1 over x. That's the hardest thing I will ever ask, and I'm only going to ask it once on the homework. But all of our derivatives we should have memorized. Let's try it. So, normally our first step whenever we have a limit is just plug it in, right? If I plug in 0, sine of 0 is 0. Plug in 0, 0, this is 0 over 0. Sad face. Yeah, that doesn't work. So, how do we do this? And you're thinking, okay, well I can do, if the higher degree, both of them have the same degree, magic fraction, that magic fraction doesn't even work on this guy. How are we going to do this? And the answer is El Hospital's rule. So, take the derivative of sine with a quiet raised hand. Who has the derivative of sine? What is the derivative of sine? Eva?
Cosine.
Cosine. Is it positive or negative cosine?
Positive.
It is indeed positive because S stands for same. Only when we go backwards do we have to worry about anti-same. All right, what is the derivative of x? Everyone's going to shout out. 1. Good. Okay, then plug in again. So really what we should have been writing is this is still the limit as x approaches 0. Now I'm going to find cosine of 0 with a quiet raised hand. What is cosine of 0?
0.
With a quiet raised hand, what is cosine of 0? What is cosine of 0? Oh my gosh, one person knows. Yes, Arrow.
Is it 1?
It is indeed 1. Done. Box it. Which is interesting because that means when we had the indeterminate form up here, 0 divided by 0, in this case it's 1. It'll be different for different functions. All right. So sometimes it's not that easy. This one was, I call easy in quotes because yes, you had to use L'Hopital's rule, but it was just take the derivative, and you're done. You just plug it back in. You have to do a little bit of trig. But this one is going to be harder because we have to use L'Hopital's rule more than once. And you might be asking, well, why? Let's see. Let's take the first derivative. Someone take the derivative of the top. Help me out. Quiet raised hand. Derivative of the top. Geo, go.
15x squared minus 8x.
Perfect. This is still the limit as x approaches infinity. And derivative of the bottom. Someone else. I'm going to cold call people that haven't volunteered. Sorry, Evan, I want to give it to someone else. Yes, Chris. Derivative of the bottom. Bring 3 down in front. 3 times 7. And then x to the power of 2. Keep going. Plus. Careful. Derivative of 2x is just 2. Yeah, nice. All right, and then we plug in infinity again, and I get infinity over infinity. I still have the indeterminate form.
We just do it again.
Do it again. Take L'Hopital's rule again. Now I have limit as x approaches infinity of the next derivative. So take the derivative of the top. Quiet raised hand. Who's got this? Someone new. Someone new. Practice taking your derivatives. Andrea. 30x minus 8. Perfect. Another quiet raised hand. Who has the bottom? Derivative of the bottom. Yes, Teflon. 42x. All right, let's plug it in. Infinity over infinity. Dang it! It still didn't work. Let's try it again. Take L'Hopital's rule again. Quiet raised hand. Yeah, James.
30 over
30 over 42. And I should still be writing my limit as x approaches infinity. Perfect. And now plug in infinity. Oh, there's no place to plug in infinity. Their answer is now 30 over 42. And we can reduce that. The top and bottom both have a common factor of 6, I think. So divide by 6, divide by 6, divide by 6, and I get 5 over 7. Final answer, box it. You might have to do L'Hopital's rule multiple times. But there's a connection here. Does anyone see it to things that we've done before? Look at this problem in its entirety.
It's magic fraction.
It's a magic fraction. L'Hopital's rule is the long way of doing a magic fraction. Come back here. It was the same degree over the same degree, which means we're supposed to be doing magic fraction, and magic fraction states, hey, just take the coefficients and you're done.
How come none of us noticed that?
Because we trust our system.
Oh, that's how faiths and cults are created.
We're too
You just trust me and go with it.
3.
That's not how math classes should work. But yeah, thank you for noticing that. That's all I have, I think, for the notes. Oh, I do have one final example. So this example is hard, and I don't expect everyone to be able to do this. But I did put one of these on the homework. The very last question, number 12 on the homework, is hard. And if you don't get it, that's fine. It's probably not going to come up on any test. It's not going to come up on any of my tests. But I just want to give you a flavor of like what true hard calculus looks like. That's not a fraction, but check it out. It's still an indeterminate form. If I plug in infinity, e to the negative infinity is really divided by e to the positive infinity. So I'm left with negative infinity divided by positive infinity. And what am I really doing here. In case you didn't catch the words, really what I have here, if I plug in, I'll have negative infinity times e to the negative infinity, which is the same thing as negative infinity divided by e to the positive infinity, which is negative infinity over positive infinity, which is indeterminate form yet again. So it's still one of the forms I'm trying to teach you guys for our objective, right? Our objective is infinity divided by infinity. This is negative infinity divided by infinity. So how are we going to solve this one? This one seems difficult. What are we going to do? And I'll show you because you've never seen this before. I can rewrite this as a fraction. So I can say this is now the limit as x approaches negative infinity. And I can choose one of two things. I can either say this is x over e to the negative x, or I could have said that this is e to the x over x to the negative 1. So I'll show you bad things happen if you do the other way around. If you did the limit as x approaches negative infinity of e to the x all over x to the negative 1, when I take the derivative of x to the negative 1, it turns into negative x to the negative 2, which then turns into 2x to the negative 3, and this never, ever, ever goes away. So this is another way of writing it, but it doesn't work out. You can try the math, it doesn't work. This one does work out. So let's try it. Use L'Hopital's rule. Quiet raised hand, derivative of the top, nice and easy. Quiet raised hand, Sego, is... Sego, say it now. 1. And what about the bottom? Quiet raised hand. This is a little bit hard because you have to worry about eating our yummy, yummy dinner. Gio? Negative e to the... Careful, just leave it. Negative x, yeah. Negative e to the negative x. Because remember, the derivative of e house, you just rewrite e to the negative x, but then you have to worry about multiplying by dinner. The derivative of that negative x is negative. Okay? And I keep forgetting to rewrite the limit to be formal about it, but there it is. I basically have to turn it back into... Here, so let's rewrite this. This is the limit of, as x approaches negative infinity of this thing, which is now the limit as x approaches negative infinity of negative e to the positive x. Okay, now I don't know why I wrote an equal sign there. Now I can plug in negative infinity. So I can say this is now negative e to the negative infinity. I'm just plugging in the negative infinity. It's not really plugging in, but this is how you think of it. And that's going to be equal to negative 1 over negative e to the positive infinity, which is equal to 1 over infinity, which is 0. That is a hard problem. I'm only going to be giving you one on the homework. I'm not going to be testing you. I'm not going to be self-checking you on these. I don't think. I haven't made them yet. How about this? I'll make it an extra credit question on the test, if you know how to do these. We are now done with the notes. Now's a good time, yeah.